a little review before we go on to the next one. We're learning about trigonometry. We've learned that you label the angles or the vertices with capital letters. You label the opposite sides. So this 3, we could refer to it as little d. Little f would equal 4. If you wanted to find e, little e, you could do a squared plus b squared equals c squared in this case and find out that the other side is, oh, does anybody know this triangle? This is a beautiful triangle. It's the famous triangle because it's not only is it a right triangle, but it's famous because a squared plus b squared equals c squared. This one's 5, and the numbers work out all nicely. Most of the time, one of them's a square root where you have like decimal places that go on forever. But this one works out nicely. What's so famous about the 3, 4, 5? It is the smallest Pythagorean triple.
And you have like a 1, 1, 1.
Right? No, you can't make a 1, 1, 1. Oh. Not a right angle one. Because 1 squared plus 1 squared isn't 1 squared. Okay? So, okay, hold that thought. I'll show you some more famous ones in a bit. But right now, so far, with tangent, what we've had so far is we know how to label triangles, and we're leaning towards learning about this acronym. And so far, we've only learned the TOA. And the TOA is an acronym to help you remember the definition of tangent. Tangent of an angle. So if I put in angle D here, because this is one of the ones that we did, well, tangent is always the opposite side divided by the adjacent side. That's our definition of tangent. And so if in this triangle, if I'm using angle D, then the opposite side is 3, and the adjacent side is 4. So opposite is always the one straight across from it, and adjacent, the word adjacent in English means beside, but when trying to figure out which beside should it be, the 4 or the 5, well, the 5 is always your hypotenuse. So when you're looking for the adjacent side, it's not the hypotenuse. So we would say that tan of D is 3 over 4. And the powerful thing about triangles is there's only one angle that's going to work to make that opposite side 3 and the adjacent side 4. And your calculator has that built into it. So we're going to figure out how to use our calculator to get that angle. We're going to figure out how we can use the angle to help us figure out sides. Working with tangent right now. So the tangent ratio can also be used to find an angle when you know the opposite side and the adjacent side. And we're going to learn a new button on our calculator, which is above the tan button. You'll see it written as tan inverse. And that undoes the ratio to find the angle. And this is where your calculator is so powerful. So in this question, determine the measures of angle K and angle N. So we start off by writing the definition. If I want to find angle K, then I know that tan of angle K is equal to the opposite, and this triangle is drawn upside down and sideways. So if I'm thinking about angle K, what is the length of the opposite side? 9. What is the length of the adjacent side? 13. What happens if I had the 13 here and I didn't know this side? I would have to first use a squared plus b squared equals c squared to find the other side before I could use tan. But right now, we have the opposite side. We have the adjacent side. So we go to our calculators. If you touch your mode button, if it's not frozen, there we go. Touch your mode button. Sometimes if you haven't used your calculator, it might be, as mine is, highlighted radian right here. There's 2 ways to measure an angle, just like there's imperial system to measure heights or the metric system to measure heights. we're going to work in degrees because that's what you're more familiar with. So make sure that degrees are highlighted. So after pushing your mode button, just do a check to make sure that degree is highlighted. And then to get out of this screen, push your second button and the mode again, because above it says quit. And that brings you back to your main screen. So we want to find the angle in showing our work on our page here. Basically, what we're doing, the mathematics behind it, because this is an equation, okay? When you do an equation, what you do to one side, you do to the other side, right? If you had to add 5 to one side, you add 5 to the other side, right? I think the only time you've really used inverses without knowing it is questions like, if you had x squared equals 9, what would you do to both sides to get x by itself? Square root. Because square root undoes squaring. Does that make sense? And in mathematics, when we have something that undoes something else, we call it an inverse. Okay? And so for tan, here you would square root both sides. Do you remember the special rule? Oh, it's just 3, right? Do you remember the special rule when you square root both sides? Did you learn that? Can be negative or positive, so we have to add a little extra to that. That could be positive 3 or negative 3. Now, what undoes tan? The inverse of tan. Now, one of the things in trigonometry is often people don't show this next step. The next step, here's tan k equals 9. Oops, I'm going to write it with a space here. The next step is on this side you take tan inverse, and on this side we take tan inverse. But partially because mathematicians are lazy, they don't like writing lots of letters down. I know that's like, I just wrote 6 letters. And I'm like almost at my quota for the day. Okay? So mathematicians are lazy, so sometimes they go directly from this just to write k equals, because the tan inverse and the tan cancel each other out, just like the square root and squares cancel each other out. K equals tan inverse of 9 over 13. And that I can type right into my calculator. And this is where your calculator is so powerful. It has memorized that if you have a triangle where the ratio is 9 divided by 13, which is some nasty decimal, the angle has to be 34.695,15353. That's fascinating. Does it say how much nearest tenth? So we would round this 34.7 degrees. We have to include our units. The degree unit is tiny and small and just a little circle above the 7. And it's easy to forget, but it needs to be there so that we show that our answer is in degrees. I will solve for n using purple, just so that our math stays separate. And sometimes when you're doing your notes, you might want to use different colors at different times to help you keep things separate. 2 ways that I can solve for angle n. I could use tan. The definition of tan says tan of angle n is equal to, opposite is 13, adjacent is 9. So angle n, in my head, I take tan inverse of both sides to undo the tan. But because I'm inherently lazy, I'm just writing this next step, 13 over 9, which is what I will type into my calculator. So I go second tan, 13 divided by 9. And I get 55.3 degrees. Remember the degrees sign. So I could use the definition of tan to find angle N as well. Can you see another way that you could have found angle N using math you've learned in the past? Yes, Bridget.
Because you know it's a 90-degree angle.
Right, we know this is 90.
90 and the angle of 10, okay?
Right, 34.7.
And then subtract that from 180, and then what you get.
So she's saying that angle N would be the same as 180 minus if we added these two together. Okay, so mathematically converting what she just said into a mathematical equation, she said add these together first, so I put brackets around there to show that we're adding them together, and then subtract that from 180, and sure enough, you get 55.3 degrees again.
On your test, would you want us to show the intermediate step with the 10 minus 1?
This one right here? Yes.
No, like...
No, this one right here?
Yeah.
With all those extra letters? No, you don't need that one. If you, I mean, I like to show it. I like to talk about it each time. That's way too many letters. 6 letters. Whew. I don't mind the minus 1. That's a number. But the letters, my goodness. But I think it's important to see it because it's not just magic. Okay? It's not just magic that we go from here to here. We're undoing what we did, and that's what the tan inverse does. But typically, because it is writing a lot of letters, often students, we just go from here to here. I just don't want you to forget that little step. Still, you have to still think about it every single time. Okay? So on your test, if you just put some invisible brain cells in between those two steps, then I can see that you thought about it and you're fine. Gotcha. Good. Nice. So now we have our calculator has 9 over 13 memorized, and it tells us it's 34.7. 9 divided by 13 is 0.6923. Okay? I'm going to put theta for an angle. I'm going to put that 9 over 13 as 0.6923 to the nearest 10,000th. Can you write this as a fraction? Well, if I go all the way to a 10,000th, that means that's my fraction. 6,923 divided by 10,000. Can you draw this right-angled triangle from its definition? I'm not drawing this to scale. If this was meters, that would be crazy. But if this, you decide, is your angle theta, and this is my ratio, the definition of tangent says tangent of an angle is the opposite side divided by the adjacent side. So I could draw a new triangle where this side is 6,923 and this side is 10,000. And if I go to my calculator and say, I want to find angle theta. Well, angle theta, I would have to do tan inverse of this side, tan inverse of that side. Mental math, okay? Based on what we did, you should be able to mental math this to 1 decimal place. If we really understand trigonometry, we could now do this with mental math. I'll show you the answer though. Okay? Tan inverse. oops, that's not tan inverse, second tan inverse. 6,923 divided by 10,000. Mr. JR, there's no way I can mental math that. I get 34.69. 34.7. Wow. How did I mental math that? It's the same answers we had here. Why is it the same answer? It's the same triangle, just bigger. The ratio of the opposite side over the adjacent side in this triangle is 9/13. 9/13 as a decimal is 0.6923. I took that 0.6923, I made it into a new fraction that was bigger. So all I did was take that triangle that we had originally and made it bigger. But that's the power of trigonometry. If you keep the ratios the same and make a triangle bigger, then the angles stay the same. We would say that those two triangles are called similar triangles because they're the same shape, just one is bigger and one is smaller, right? If I'm standing at this triangle right here, this triangle looks really big, right? But if I run to the back of the class and I look at it now, it just got smaller. But does it make sense that the angles haven't changed? So that's the power of trigonometry in that if the ratio stays the same, the angle stays the same. And so if you can figure out the ratio and put that into your calculator, the calculator says, oh, it doesn't matter how big or small the triangle is, I will tell you what angle goes with that ratio. So here is this application to the solar panels that we talked about yesterday. Clyde River on Baffin Island has a latitude of 70 degrees because it's so far north. So if you were building your house and you wanted to put the solar panels right on your roof, it probably wouldn't be a very good idea because your roof would have to be so steep that you would have either a really tiny house with a big roof or a huge house with a roof that goes up like 17 stories just to get the angle right. So what do? Well, they build like, here's your roof, and they put like support things on there so that it's tilted up at the right angle. They don't just lie it down flat on the roof. Okay, but here's a diagram showing the side view of the solar panels. And they designed it so it was 70 centimeters this way, 208 centimeters up. Is this a good design for Clyde River? What do we need to know? We need to know what this angle is. So when we don't know an angle, the most common symbol for angles that we'll use is theta. So I need to find that angle theta. And if that angle theta is 70 degrees or close to 70 degrees, this will be a good design. If that angle is not 70 degrees, then this design won't be very good. Well, we can use our definition of tangent and say tangent of that angle theta is 208 divided by 70. So if you did 208 divided by 70, you'll get close to 3, probably like 2.8 or 2.9. And if you had to use the tables, you'd have to flip through the tables until you found 2.9 and find out what the angle is. But our calculator has it built in. If we do tan inverse of both sides, that will solve for our angle. So we go to our calculator. Tan inverse of 208 divided by 70, 71.4 degrees. So what would I say was 71.4? I'd say that's pretty close. It is a good design because it is close to 70 degrees. So our last example for today, a support cable is anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long. It is attached near the top of the pole. What angle to the nearest degree does the cable make with the ground? So what we're going to find with word problems with trigonometry is you're going to need to draw a diagram. So we need to draw a telephone pole. There we go. There's our pole. 5 meters from the base of the ground, there's a cable. So this will be a length of 5, and that's where the cable is attached to the top or near the top of the pole. And the cable is 19 meters long. What angle to the nearest degree does the cable make with the ground? So the cable and the ground, they're talking about this angle here. What's the problem if I go tan and write out my definition? We don't have the opposite side. We know the adjacent is 5. Instead of using a question mark, are you okay if I put a letter X here saying, oh, I sure wish I knew what that other side was? Because then I could use tangent. Are there any options other than quitting and dying? A squared plus B squared equals C squared. That does sound a little bit better than dying. Okay, so I could do A squared or X squared plus B squared, 5 squared equals C squared, 19 squared. Okay. Pick a square that you'd like to do. Mental math. Do you want to do the 5 squared or the 19 squared? Oh, so what is it? 25. 19 squared, 361. What do you have to do to get the x squared by itself? Subtract 25 from this side. So that will leave you with 336. 336 is not a perfect square. This is not a nice triangle. So you would have to go to your calculator and square root both sides. So square root of 336, and we get 18.33. Technically, mathematically, if I was doing my work perfectly, I would put plus or minus here. But since we're dealing with a length, here I'm going to be proper. I'm going to put plus or minus, make it look nice even. X equals plus or minus. But then I'm going to write, well, the only one that makes sense, because we're dealing with a measurement, is the positive value. Well, if you're dealing with lengths, never, right? Unless you're dealing with lengths that it could be above the ground or below the ground, but they never told us how the pole was. Then the negative length would show that it could have been below the ground. So sometimes direction comes into play where negatives might make sense. But for the most part, are values that are positive are what makes sense. But now we can go back and say, since I know that x has to be 18.33, I know that tan of theta is equal to 18.33 divided by 5. Yes?
So when we're doing this in test question
Mhm.
test, would you want us to store like the whole 18.33?
Yes. So we're going to need to use all the values. And one of the ways that you could do that is you could temporarily store that value as x is one way that you could go about doing that. Another way that you could do that is, and I'll show you both ways. So I've stored it as x, and x is my favorite one to store as because it's the easiest button to push. And now my calculator remembers that if I push x, what's x equal to? Oh yeah, it's 18.33. Now, if I want to find my angle theta, I would do tan inverse of 18.33 divided by 5. So there's two ways you could do that on your calculator. You can either, if you didn't store it, and you're like, oh, I want to use this answer that I just had, above your negative sign is ANS. That is short for answer. So you go second, answer, divided by, what was it divided by? 5? And it tells us the angle is 74.7 to the nearest degree, 75 degrees. But if you did store it as x, you could have gone tan inverse of x divided by 5. And since that's the same number, it comes out as the same result. 74.7 to the nearest degree. Is it to the nearest degree? The question? So that would be 75 degrees. We're now going to work on our homework, but before we get there, okay, I've introduced this already. So katoa, we've only learned technically the definition of tan. If I look at that triangle and I look at theta, which were the sides that we were given? We were given the adjacent side and the hypotenuse. Changing colors here, which of the three trig functions has the adjacent side and the hypotenuse? Cosine. So I want to show you something in purple here. You're not supposed to see this yet. This is supposed to be our lesson like 2 days from now. So if anybody asks, you have no idea. You haven't learned this yet. Okay? But if the definition of cosine is adjacent over hypotenuse, and I work at this the same way that I work at definitions with tan, I would say cos of theta is adjacent over hypotenuse. Any ideas how I might be able to use my calculator to find theta? What do you think would be the opposite of cos? Cosine with the negative 1, which is cos inverse. So let's see what happens if we do that. Cos inverse of 5 over 19. So we need to find on our calculator cos inverse button, which is right over cos. 5 divided by 19. Exactly the same. So you have to ask yourself later on, if we look at this whole page at once, to use tangent, we first had to do a squared plus b squared equals c squared, which is all the green work, before we could do all the work in blue. If we know all three trig ratios, sine, cos, and tan, and their definitions, there's always going to be one that can do it faster. In this case, since we knew the adjacent side and the hypotenuse, if we use the definition of cosine, we get the answer in just 3 purple steps. Wow. And so that's why your calculator has a definition for sine, a definition for cosine, and a definition for tangent.
Wait, so they're trying to find the exact same thing,
They're finding the exact same thing,
just with different.
just with different ratios. And so if we go back to our 3, 4, 5 triangle, so if I just add a page here, here's this famous 3, 4, 5 triangle. Actually, this looks like 4, this looks like 3. Okay? There's the famous 3, 4, 5 triangle. If I put theta in here, by definition, tan of theta is 3 over 4. By definition, cos of theta will be 4 over 5. And by definition, sine of theta will be 3 over 5. If you do tan inverse of 3 over 4, or cos inverse of 4 over 5, or sine inverse of 3 over 5, your calculator has all of those values memorized to be that same angle. And they'll tell you what that angle is. The reason they have all three memorized is because sometimes you're given this triangle, oh, but they didn't give us this side. Other times they're like, oh, we have this triangle, but they didn't give us that side. Or you have this triangle and they didn't give us the hypotenuse. And you could find the hypotenuse with a squared equals b squared, a squared plus b squared equals c squared. But if you don't have to and can find it directly, that might be better. Yes? They're trying to find the angle with this specific triangle.